Hello everyone. So in SYBSC chemistry paper, we have two papers, as you already know about the syllabus of university, that for second year of BSc we have two papers. First paper is comprising physical and analytical chemistry, and the second paper is comprising of organic and inorganic chemistry. So in paper first there are again two sections. So the first section is having physical chemistry part, and the second section is having analytical chemistry part. From today onwards I am going to teach you the analytical chemistry part. Okay, dear friends, the first chapter in this analytical chemistry is errors in quantitative analysis. Errors in quantitative analysis. The background of this topic, or the introduction of this topic, is well known to us, that while doing any experiment, that is actually quantitative experiment, when we are doing volumetric analysis, that is titrimetric analysis, some errors may be occurred in our measurement. For example, from last 2 to 3 years we are doing different types of titrations in the laboratory, and if the teacher is expecting, or the experimental methods is expecting a particular correct value, but we know that different students while performing the titrations get different results. The different measured value or the observed value of that titration, burette reading, let us say, is different. So means what happened here? The error is occurred. If suppose the correct value is 10.0, correct measurement of the burette is 10.0, but you get 9.5, some people get 9.0, some people are getting 9.8, some are getting 10 point above than 10.0, that is 10.5, 10.7, 11.0, etc. Means different students can get different observed value for that particular titration, for the same titration, let us say. So what is this? So we can simply say the errors is there. There are errors occur in the measurement of the burette reading. Okay, so this is all about the quantitative analysis, or errors in quantitative analysis, let us say. Okay, so while doing, or while performing, or while studying the errors in quantitative analysis, two aspects are most important here, and these two aspects are known as accuracy and precision. Accuracy and precision. The accuracy and precision are two different things, actually, two different things. We will see one by one. Accuracy and precision we will see one by one. First of all, we will see what is meant by accuracy. Accuracy. So what is this accuracy? This accuracy is related to the correctness of the measurement, correctness or closeness of the correct value, closeness of the correct value of that particular measurement. Okay, it is related to the closeness of the correct value, closeness of the correct value. How your answer, how your observation, how your value, that is observed value or measured value, how it is close, how much it is close, that is nothing but the accuracy. Okay, means we can say, if some student is getting exact answer, so we can say that it is highly accurate answer. In the same way that accuracy can be explained. Okay, let us see the definition of accuracy. So accuracy can be defined as the agreement between the correctness or the degree of agreement between the measured value and the true value. Degree of agreement. Degree means we can say how much. In other words, we can say that it is degree of agreement. Degree of agreement between the measured value, we can also say that it is an observed value, and true value. So this is a simple definition, that accuracy can be defined as the degree of agreement between the measured value and the true value, that is correct value. Okay, so it is nothing but the just comparison, or we can say that the comparison of the true value, that is measured value, and correct our true value or correct value. Means some experiments are already performed by the experts, and they have obtained a particular data, and that data we call that data as a perfect data at particular conditions. Okay, so that data is related to or it can be compared with the observed value or the measured value, we can say. So this is the degree of agreement between the measured value and the correct value, or the observed value and the true value. Okay, this is nothing but the accuracy. Okay, then the second thing in this is the precision. Okay, similarly, just like accuracy, we can also see the definition and the concept of precision. Okay, so the precision is again another thing. In quantitative errors, while discussing the errors in quantitative analysis, this accuracy is different and precision is different. This precision is related to the reproducibility. It is related to the reproducibility. So what is this reproducibility? Means how many times you are getting the same answer, you are getting the same observation, you are getting the same measured value. This is called as reproducibility. Means again and again, how many times you are getting the same value for that observation, that is nothing but the reproducibility. So precision is related to the reproducibility of the observation or the observed value. Okay, so just like accuracy, we can also define the precision. So what is the definition of precision? Precision can be defined as the degree of agreement between reproducibility, degree of agreement between reproducibility of similar measurements under identical conditions. Very simple definition of precision is there. So what is the precision? First of all, we have we must keep in mind that precision is related to the reproducibility of the results, reproducibility of the observations. Okay, once you keep in mind this thing, reproducibility of results, then you can easily find out, you can easily try to write the definition of precision. That is, it can be defined as the degree of agreement between reproducibility, of number of similar measurements under identical conditions. Reproducibility of number of one word was missing, number of similar measurements. How many times, how many numbers that our measurement is repeated, we are getting the same answer, we are getting the same observation. Reproducibility of number of similar measurements under identical conditions. Okay, so this is the concept of accuracy and precision. Okay, so these are two most important things while discussing the errors in quantitative analysis. Okay, then we will discuss the next topic is the methods of expressing the accuracy and precision. How we can express this accuracy and precision. Okay, so there are some methods, we will see one by one. First of all, we will see the methods of expressing the accuracy. Methods of expressing the accuracy. Actually, accuracy can be expressed in two different ways. The first one is absolute error and second one is relative error. Absolute error and second one is relative error. There are two ways we can express the accuracy. The first one is absolute error and second one is relative error. Okay, so see, first of all, the absolute error. This is the first way that we can express the absolute error. Okay, so the absolute error is nothing but the difference between our measured value and the true value. It can be defined as the difference between the observed value and the true value of the measurement. Okay, difference between measured value and true value with regard to sign. With regard to sign means the sign is important here. With regard to sign means sign is important, whether it is positive or negative value, that is important here. Okay, so what is the definition? Absolute error can be defined as, this is a difference between measured value or observed value, you can say, and the true value. Measured value or observed value and the true value, the difference between the two value. Okay, one is observed value and another is the true value. Okay, and with regard to sign means sign is important here. Okay, for example, in simple way we can make a formula for this absolute error, that is E is equal to O minus T. E is equal to O minus T, where E is, what is E? E is absolute error. E is absolute error. O, what is O? O is observed value. O is equal to observed value, or you can simply say the measured value. What actually we measuring in that particular experiment, that is nothing but our observed or measured value. This is all about the quantitative analysis. Mind well, we are discussing this chapter which is totally related to the quantitative analysis. We are already know that analysis are of two types, qualitative analysis and quantitative analysis. In qualitative analysis we are getting only information about the what is present in that particular sample, what is particular present in that sample, and in quantitative analysis we are getting the information how much of that particular substance, particular element or particular compound is present in that particular sample. That information is given or we can obtain from the quantitative analysis, and this is all about which types of error and what errors are obtained in the quantitative analysis that we are discussing in this chapter. Okay, so E is equal to absolute error, O is equal to observed value, and simply T is equal to true value. T is equal to true value. So this is a very simple way that we can have a definition and a formula for the absolute error. For example, let us try to learn more about the absolute error. If we have a sample, and the accurate weight or the correct value of the weight of that sample is 2.72 gram. This is our sample and this is the correct figure, 2.72 gram. But we are going to weigh this sample, and on our balance that sample weighs round about 2.62 gram. So what are these two figures? 2.62 is our observed value and 2.72 gram is our measured value, correct value or true value. So absolute error in this case we can calculate, that is O minus T, observed is 2.62 minus true value is 2.72. So absolute error is equal to 2.62 minus 2.72, and we get this is minus, as this figure is less than this figure, so we get a negative answer, minus 0.10 gram. So what is absolute error? What is the error? It is 0.10, but absolute error is related to with regard to the sign, so absolute error is equal to 0.10 gram. Okay, this is the absolute error in this particular example. You can take any example and you can compare the two values, correct value or true value and the observed value. Okay, this is nothing but the absolute error. Now second method of expressing the accuracy is the relative error. Now why there is a need to express the errors or the accuracy in the relative error? Because this absolute error has no significance. It has very less significance. Absolute error has very less significance means importance, because let us take an example of weighing. We have to do a particular reaction, and for that reaction we have to take some starting materials. For example, we have to take a starting material, for example, is salt, and we have to take 1 kg of salt. Okay, we have to take 1 kg of salt, but the absolute error for this measurement is 0.10 gram. 0.10 gram means 0.10 gram or 0.10 milligram. 0.10 milligram. Okay, let us say. So as compared to 1 kg, this 0.10 milligram is very less figure. Okay, it is very less figure. But for that same reaction, if we have to take a particular organic compound and the weight of that organic compound is 10 mg, sorry 10 gram, 10 gram we have to take, or let us say 1 gram, very less amount, 1 gram we have to take. And if the absolute error, the previous one, absolute error in this case, if it is 0.1 mg, then as compared to 1 gram, this 0.10 milligram is a significant value. Okay, so this can be, we cannot neglect or we cannot ignore this 0.10 milligram while weighing the organic compound in particular reaction. But for as compared to 1 kg, this 0.10 milligram is very less. So in both of the cases, the absolute error is 0.10 milligram. So that's why in this case we can say that the absolute error value has no significance particularly, because if we are, unless we compare the correct value or the true value, then the value of absolute error has no significance. Okay, then the second one is relative error. Relative, again relative means in relation to other. Okay, this name itself indicates the relative error is nothing but a name, it's in comparison with error in comparison with other. Okay, so it is nothing but a ratio. Relative error is nothing but a ratio. So so ratio of, it is the ratio of absolute error divided by true value. Absolute error divided by true value. Okay, so relative error is nothing but absolute error divided by the true value. Absolute error divided by the true value, we are getting relative error. Okay, so relative error is equal to absolute error divided by true value. Generally, this relative error can be expressed in terms of percentage relative error or parts per thousand. If we have to express this into in percentage, then we have to multiply this ratio by 100, we get this in percentage. And if relative error, if we have to express in parts per thousand, that is PPT, parts per thousand, then we have to multiply this ratio, this figure, that is absolute error divided by true value into 1000. Okay, so these are the two ways of expressing the accuracy in two ways. Okay, relative error and absolute error and relative error. Relative error can be expressed into two ways, in percentage as well as in parts per thousand. Okay, PPT. So this is the concept of relative error, absolute error and relative error. Now this relative error has no units, because as it is a ratio, because it has, that's why it has no unit. Okay, then we can have the one particular example is there. In this case, we can understood the concept of accuracy and precision here. Okay, accuracy and precision can be explained with the help of this chart, or let us say this graph. Okay, what is this? These are the persons A, B, C and D. The 4 persons or 4 students are taking a measurement in titration, and 14, 15, 16, 17, 18, 19, these are burette reading. Okay, 17 is the true value, that is shown by dotted dots. Okay, 17 ml is the 17 ml of burette reading is the true value of that particular experiment. The person A or student A is getting first attempt the correct answer related to 16 ml. Then in second, third and fourth try he is getting the answer beyond 18, means between 18 and 19 ml. Then the person B is taking 4 observations, and all the 4 observations are in between 15 and 16 ml. The person C is taking 4 observations, and all these 4 observations are close to 17 ml, while the person D is taking 4 observations and all are in between 16 to 18 ml. From this data or from this chart we can conclude that the person A is having a good precision, because here is reproducibility of the results is obtained, good precision but poor accuracy, because accuracy is not there. Actual or correct value or true value is 17 ml, but the person A is getting the observations beyond 18 and 19 ml, and first observation was near 16 ml. Okay, so it is good precision but poor accuracy. Then person B, what about person B? It is again having good precision. Okay, the results are reproducing on the nearer value, so good precision is there but poor accuracy is there. Then person C is having good accuracy as well as good precision. Because why good accuracy? All the 4 observations are related to nearer to 17 ml, and the precision, why it is good precision? Because all the observations are related to one another, very close to one another, and they are reproducible, means 16.8, 16.9, 17.1, 17.2. so that person is getting the reproducible results. And D is again poor precision and poor reproducibility, that is poor precision and poor accuracy, we can say that. So from this data we can see or we can understood the difference between accuracy and precision. Okay, now one more one more chart is there to compare the relative error and absolute error. Okay, so for example, if we have to take the, I can rub this, if we have to take the measurement of 10.544 gram, this is true value, this is true value. Okay, and you are getting your observations or observed value or measured value for this particular observation is 10.545 gram. Okay, then what is the absolute error? Absolute error is difference between observed and true value, so it is 0.001 gram, 0.001 gram, and the relative error in parts per relative error in PPT, means in parts per thousand, is what it is. By calculation it is getting 0.94. Okay, so this is about a larger figure is there, the true value is 10.544. Now in case of smaller value, for example the true value is 0.104 gram, the true value is 0.104 gram, and we are weighing this value or the observed value for this is 0.105 gram. Again, what is absolute error? We can get the same result that is 0.105 minus 0.104, we are getting the same value as like this, it is 0.001 gram. Now what is the point to be emphasized here? In both of these cases, absolute error value is same, that is 0.001 gram, but the relative error in both of these cases is very different, okay, and in this case it is 9.6. If we do a calculation by using calculator or calci, then 0.001 divided by the true value 10.554 into 1000, because we are expressing it in parts per thousand, you are getting the value 0.094, and for this 0.001 divided by 0.104, you are getting the answer into 1000, you are getting the answer 9.6. So these two figures indicating the difference between relative error of these two experiments. This is a larger value, so that's why the relative error is very less in this case, okay, because absolute error is 0.001. In both of the cases the absolute error is same, but here the relative error is very less as compared to this 9.6, okay. So from this figure we can say that why absolute error value has less significance as compared to relative error, okay. So this is the main difference, or what is the need actually for the expressing the accuracy in relative error instead of expressing it in the absolute error, okay. So for this we are concluding today. What we have learned today in today's lecture, that the introduction of errors in quantitative analysis, which types or what errors are occurred in the quantitative analysis. Actually the different names and the different terms used in these errors are we are going to see in the next videos, in the next lectures, but actually the background of this chapter is accuracy and precision. What is the difference between accuracy and precision? What are the methods of expressing accuracy and precision that we are to learn today. So thank you students, see this video properly, and I am also providing you the notes, photos of the notes in photos or in PDF as per your needs. I will prepare and I will send on your WhatsApp group, okay. Thank you.